Okay. Well, thanks for coming, and thanks, Andrew, for the invitation, the organization. I'm going to be talking about GeoGet. If you see the program, it says GeoGet. That was the old name. We're changing to this new name. GeoGet is almost the same, but we have changed one letter for some reasons. But this is basically a system for versioning spatial data. So what I'm going to do is introduce you a little bit the main ideas of versioning for spatial data. Then we'll see a little bit about GeoGet itself, just the software, and then at the end maybe we'll make a small demo so you can see it in action and get an idea of what it's actually right. So basically what a GeoGet is a system for versioning spatial data that is inspired by Git. I don't know if any of you is a programmer and you're familiar with Git. It's a software for versioning source code, right? So the idea is to bring the same ideas that we have in Git, but to the realm of spatial data, right? Probably if you know Git, you know GitHub, and you see that in GitHub right now you can use Git to upload your GeoJSON data, and it kind of have some interface that it shows you your spatial data, etc. So there's no reason why you shouldn't use Git or why you cannot use Git for versioning your spatial data, as long as it's kept as text, like in a GeoJSON. But there are some limitations because actually Git was not designed to work with the spatial data. And if you think, for instance, in a very large amount of data, like let's say the OpenStreetMap planet. I don't know if you're familiar with OpenStreetMap. It's a massive amount of data. If you try to put something not even like that, but orders of magnitude smaller than that, Git is not going to be enough because it's not designed for that, right? It's designed for a different size. It's designed for a different kind of data. So the idea is to get with GeoGet is to get the same philosophy, but having a software that is specifically adapted for this kind of data, right? So basically that's it. That means that if you are a Git user, you're going to get pretty quickly with GeoGet because you're going to have the same operations, the same workflow, right? And even the same commands. The commands look really the same, really similar because we've taken a lot of inspiration from Git. But then there's some differences, and internally it's completely different. And although we were using the name GeoGet to make a reference to Git, now it's GeoGet. But although we're taking inspiration even in the name, it's not based at all in Git. So it's a software that is completely new, is written from scratch. So we just take from Git the inspiration, the ideas, or even the name, but not the software itself. So it's not an extension for Git or something based on Git, right? So what is the advantage of having something like Git? If you're familiar with software development, you can see that this distributed version control is one of the most important things that probably has happened in the field in the last decade, because it had changed from the model that you have a central repo and then we have people working based on that to a really distributed version where each person that is working on that project has a full copy of the repo, including all the history and everything. So you basically have one repo that you can consider the central one, like the one that you have in your GitHub account, for instance, but everyone that is working has exactly the same content, right? So that means that they have everything you can do on the central one, you can do on your local one, right? And those are, this is like the main advantage of Git, and we're trying to bring that to spatial data, and as I will explain, that brings some advantages as well, and it's going to give us the chance of doing very interesting things for keeping and for managing our spatial data, right? So this is the place where we're keeping the software. It's an open source software, and it's part of LocationTech. And well, we can consider that it's feature complete in the current version, which is 0.9. And by feature complete, I mean that what we have now, it basically has more or less all the commands that you have in Git. That means that you can make the normal workflow that I will explain a bit later, but the normal workflow of just taking your data, putting it into a repo, creating a new version, then changing that with another repo, etc., like pushing, pulling data. You can do all that, right? We have all the functionality. There are, of course, still things that we have to do. We are going to, I will explain later, but we are going to improve more the scalability. That's one of the things that we are working more on that, to be able to actually have very large repos. But in terms of functionality, that is complete, right? The basic idea is that the same that has happened with the not geodata, with source code in case you're using it. The future is distributed. It's a better workflow. It's a better way of working with that kind of data. The same that happened with source code. The same happens here with geospatial data. So we really believe that this is the best way right now of working with your data, keeping your history, and also collaborating with other people that are working on the same data, right? So why is that we have started writing this software? First, as I said, because Git is not enough. I mean, if you try to use Git, it's fine for small scale projects, but it's not something that is meant to be used for geospatial data. But also there are reasons why we believe that this is a good idea, a good software to create, and this is what I'm going to tell here. The first one is that the history of geospatial data it's important. It's actually very important, and it's something that people usually neglect. On the one hand, the data itself changes. If you're having, let's say, the data of here of the city of Toulouse, that changes. You might have a new street, a place you have. In your cartography, you have a shop, and now it's not a shop, it changes into a bar or whatever. So the history, it's important because the data itself has some history, right? So it's important to keep track of that, and don't keep it separate because it's the same data. So it's more interesting to have it in a central place where you have the same data and different versions, not different files or not different things that represent the same data at different moments. The second reason why this is important in your history is because you don't make all your data at once. You don't go to Toulouse and take all the data at once. There's several people during 1 month, 1 year, or whatever the time that slowly evolve that data. And it's interesting to keep track of that. Keep some traceability so you know who has edited what, etc., etc. So it's the same that happened with source code. It's the same thing that you see in Wikipedia. You see who has edited an article in Wikipedia. You can go back to any version if you like it, etc. So that's those are the two main reasons why we can say that history is important. And there's not a system currently that allows you to do that. Not an open source, especially an open source software that allows you to do that. So that's the main reason why we started writing GeoGet. The advantages that this has is they're all mainly due to this fact that we have a distributed version system. That means that we have all the history and all your data, and every person that is working on that is going to have a full copy of that. So that's the advantage that you get in the case of working on source code with Git, and the same that you have in here. So you don't have a single point of failure, even if you have a central repo that you consider like the main one, right? If that goes away for some reason, there's no problem, right? Because everyone working on the project has exactly the same data. So that means that it's much safer. I don't know if you have worked with source code and you have worked with SVN or CVS. That was a completely different thing in terms of that. It was a central one. Also, there's no single point of truth. There's no one that you can consider it's the one that holds the real or the best data. You can just all the projects, they have the same, and actually they interact. So what you end up having is just like kind of a network of repositories that all have the same content, and they just are interconnected and they share the information. So it's a better way for sharing and collaborating, which is something that is pretty important nowadays. There are crowdfunded projects, people that contribute, many people contribute to a single project, and we have this kind of tools for working with open source project, and we should have some tool like that for a case of geospatial data, so we enable people to collaborate and share the data in a better way, right? Basically, that's the structure of the workflow in a GeoGit repository. You have your data in your normal format. You can have a shapefile, you can have it in a PostGIS database, you can have GeoJSON files or a spatial database, whatever, right? And you have to put it into the what we call the working tree, which is like a kind of buffer area that makes part of the project. So you don't use actually your normal files. You just have to put your data into the repo. That means that it's not going to consider your format at all. No matter what format you have to put it in there, and then you start working when your data is on the repo, right? When your data is in the working tree, then GeoGit can compare things, can tell you what has changed, etc. So you put your data in the working tree, and then you basically move it until you put it into the repo database, right? That's where you create a commit. So you basically, you put your data, import it, then GeoGet knows about your data in the working tree, and when you're ready to create a new version, say, okay, this data, I want to call this version like the version that I did today, or after this event that I edited this data, I create this new version. And you just put a message to identify that, and you create that, and that's the commit operation that you put data in the repo database. Everything that you have in the repo database is just basically the full history of your data, right? And if you're familiar with how Git works, anyway, it works the same in that you don't have the full copy, right? If I have, let's say, one shapefile, I put a shapefile with 1,000 points, for instance, then I move it to the repo database. It's going to keep 1,000 points in the database. Then I put a modified copy of that, which I have added one more point and modified just 1 point. It's not going to put those 1,001 points again. It just stores the difference. So it's really optimized in terms of that, right? It doesn't store the actual snapshot of the data, but just the difference between the data that you put in the working tree and the previous version, right? So it's pretty optimized in terms of that. That's how it works in a Git repo, right? The last step is that you can, from your repo database, which is like the last step where you have your full history, you can move it or bring it from a remote repo, right? You have another repository, someone that is working on the same data actually, that has all the data, all the history, the same data you have. You know, that's the idea of your clone of the repo. And you can change data, you can exchange data with that other repository. So I create my data in here, I add a new version, going from my shapefiles up to a new version in the repo database, and then I have another repo that I know. It's like, okay, here's my data, I send it to you, and then I take your changes, right? So it's this exchange of data, and makes it, as I said, very good for collaboration. Right? So one of the things that are very good about the Git model is that you can create branches, and in case of working with source code, probably if you're familiar with that, in the case of source code, what you do normally is you create a branch, because if you're going to do some development that might break the code, you just create a branch, you work parallel to let's say, the main branch, and you do your stuff. Even if your code doesn't work, there's no problem, it's just on your branch. People can keep on using the main one, and then once you have a stable version of this new functionality or whatever you're doing, then you merge it, right? In the case of geodata, it's not for the same reason that it is useful, because your data is not going to break any data, right? If you start editing, you're always improving some data or adding whatever to your data. But being able to create branches easily and then merging, it's pretty useful for many things that I will describe later. But one of the most important ones is the what if scenario. So you can actually create a branch and experiment with the data, do some changes and do analysis or whatever on that branch, and then you can later merge. So the idea is that with the Git model, it's very easy and simple, and it's cheap actually to make branches, to actually have not just linear history, which is what you have in like something like Wikipedia or something like you have in OpenStreetMap. You have a linear history, right, like one version after the other. But here you can have a branch history that gives you more possibilities, and you can do more things for versioning that, right? More, you can create new alternatives of the data, and then just decide how to use that, merging them or not, right? So GeoGet is the same as Git. It's a command line interface application. That means you have a console, and you just type commands on the console, and basically it's pretty similar to the syntax that you find in Git. I have one example in here. I have created, I have put my data, created a couple of versions in the repo, a couple of snapshots of the data, and then I can just call GeoGet with a diff, and it gives me a difference between, actually in that case, between the working tree and the latest version. So you see it says, okay, the geom, that's the geometry attribute, has changed. There are 3 points moved and one point added. And this attribute called park type has changed from garden to park. And then I have another feature number 12, in which I have just moved 18 points. It seems like I have translated the whole geometry, right? So that's how it works. You have the same commands that you have in Git. If you have seen Git, it will show you the diff between two versions of the source code. Here it gives you two versions, the difference between two versions of the data, and for each one of the features that actually have changed. Right, so that's how it works. You see, it's pretty similar to to how Git is, in case you're familiar with Git, and not just get the idea that it's a command line interface application, and you have these commands that allow you to do all the code. This is a quick list of most of the commands, and once again, just like get an idea of them. If you're a Git user, you probably recognize most of them. Like you can have an add, which is like the command that you use to move things to the staging area before making a commit. You have a blame command that allows you to see who has changed that. So you take that feature, the feature that represents, let's say, street, and you say who has changed this attribute in this street, and it just gives you the information that it was this person, and it changes at this commit, which was made at this time, right? So you can actually see who has done anything. You can clone your repo, you can commit. There are a couple of other things. I will discuss the conflicts later, because there might be conflicts when merging branches, etc. There are some commands for branches like rebase or merge, which are actually the ones that take care of all the branches. There are push pull for making all the this exchange of information between repos, right? And we have a full group of commands that are called OSM that are specific for OpenStreetMap data, because we consider OpenStreetMap data as a special type of data. And to make it easier to work with OSM data, we have some specific commands that you can use just for the data, to pull data actually from the OpenStreetMap planet, etc. Well, just a basic list of commands. The branches that I was mentioning, as I said, they are pretty easy to create. And one of the most important things is for this what-if scenarios. Like the idea is that, let's say you have, for instance, the city of Toulouse data, right? And you want to make an analysis of what would be good to put some a shopping mall or something like that, right? So you can have several alternatives. I put it here, I put it there. So what you have to do is to modify your data and then do your analysis, but instead of modifying the main line of your history, you just create a branch and say, okay, this is my data with all the streets, with all the shopping malls that already exist, so add a new one here. And then I do my analysis. I can do analysis about how far are people from a shopping mall, or how that might affect the buses, how they move, or whatever. You do your analysis, but then you can create another branch and you put your shopping mall alternative in a different place, and you do the same analysis. You can have all these variants really well organized, each one in a branch. Then when you decide which one is the one that you want to keep, the one that is going to be the real one, then you just merge that one on the main line, and you can get rid of the other branches. But it's a clean way of having several alternatives in version for the same data, instead of just creating files or having different repos with that, each one with a different version of your data, right? So it's a clean way of having everything organized, tagged, and etc., right? And when I say once you create your branch and you have finished working on that branch, it's very easy to move data between branches. You move the modification that you've done in one branch, move that modification back to the main branch, right? You use the merge or the rebase commands, which basically are similar thing. The merge actually merges the two branches. The rebase actually just moves the comments. It's a different strategy for combining branches, but basically they do the same thing, combining data from one branch to another, right? One problem that might happen is when you have conflicts, what we call a conflict. And this is interesting as well. It's interesting, of course, in the case of source code, and Git has it. But it's interesting for editing geodata. Imagine that I have created this branch with my alternatives for where I'm going to put my shopping mall or whatever. And then I finally had my good alternative and I want to merge it back. But then the main line, people can keep on working on that. I can keep on working on that. Other people can put data in that and push data to here. And there's someone that changed something that I've also changed. So both people in different branches have changed the same thing in a different way, right? And it's just like, okay, you're trying to merge, but it's like, no, you started from here, you have made this modification, but someone else has made a different modification, and they're not compatible. So that's where GeoGit will find a conflict, and this is absolutely basic if you are in a scenario where you have multiple people editing the same thing, right? So this is one of the things that are needed in a system such as GeoGit, because if several people edit the same data, you must have a way of solving those conflicts, right? So you see when you try to do a rebase in this case, but actually it's going to find that there are some problems, and it's going to actually find, or when you do a merge, it might happen the same, and then you can just show that the conflict and say, okay, here, this is this feature called parks 2. So in your layer called parks, the second feature, you have changed from 0 to 5, that attribute, and someone else has changed from 0 to 2, and also modified the geometry. So which one is the good one? Then you have to solve the conflict, right? So that's something that GeoGit can control pretty well, right? That you have to solve the conflict, and this is one thing that, as I said, GeoGet is a command line interface application, but as you can imagine, this is not something that is easy to do on the command line, right? You have a polygon and someone has moved 2 points and you have moved another 2 points, or you have actually changed the projection, for instance, like, which is the good thing. You have, okay, I can take these 2 points that someone edited, but then I have to reproject back. So it's not something that you can easily do on the command line. We need a graphical three-way merge. It's the same with Git. If you are actually used to using Git for source code, Git doesn't have itself something for this conflict resolution. It relies on some three-way merge tool that you might have installed in your machine, and there are several different alternatives. There's not an alternative for that in terms of geodata, so we have created one. And the one that we have created is part of a plugin that we have for Qgis. I don't know if you're familiar. It's a geographical information system. It's a free one, open source one. And we have created a tool that actually I will show you later that you can use for handling all the GeoGet workflow, including solving conflicts, right? So this is one of the parts that the GeoGet library, actually you cannot do everything on the command lines, and the conflict resolution is pretty simple. You can just select one or the other of the option, but not do a more fine-grained resolution, right, of the conflict. So this is what I'm going to show you with a couple of screenshots, and then maybe we'll just go for a small demo. We have some things to go beyond the command line interface. We like to say that GeoGet is not actually an application, it's a library, because we see it as the base, the foundation for other things. Whenever you need geospatial data versioning, you just put GeoGet, and then on top of that you put other different things. The most basic thing is to put something that is more graphical, actually. Like, most users don't like the command line, and in the case of Git, even if it's targeted at programmers, for Git, you have several interfaces, like a lot of interfaces, graphical user interface for people that can version their source code with a graphical user interface. So we're just trying to do the same, but for GeoGet, and we are based on Qgis, because it's easy to do it, to add a new plugin, and also we get some extra capabilities by relying on Qgis. Also, we had Geoserver Integration. If you're not familiar with Geoserver, that's a solver for serving geodata. What we have done, I will explain later, but we've done is integrating that with GeoGet. So actually, the data source that you can use for serving your data for Geoserver can be a GeoGet repository. So you can actually serve data, and not just a single layer of data, but full history of the data, right? So the Qgis plugin, I'm going to get a little bit more in detail with that. It's basically we try to have a desktop solution for GeoGet, move from the command line to a desktop tool, right? Of course, we can put GeoGet-based functionality also on a web client and do things like that. But this is what we consider to be like the most typical or the main tool that the normal user will use for Git, right? So because it's based on a software that is very well known, that is very functional, it has a lot of functionality, and it integrates really well with the GeoGet idea, right? Yeah, we're working towards that functionality based like source tree, which is one of this, in case you know it, one of this graphical interfaces for working with Git, with source code. We're following the same approach, right? So this is basically what it looks like in the interface. This is the main interface. You see the history. So actually you start adding going through all this part, importing your data and creating new versions, etc. So you just populate your repo with versions of your data, and then the main dialog, the main window in the plugin is basically the history. You see a history with all the different versions, who has made each one, when, and then you see an identifier for each one of the versions. So basically that's pretty simple. You see the history, and you can go do all the things that you want to do with any of these versions. Like I want to check out this version. I mean, that I want to see after that new edit that is called added land use layer. I want to see how was data at that point and when it was done. Okay, 1 hour ago, I want to check how was that done, etc., etc. Right? So you can actually work with all the history. It's actually a pile of layers that you have, different ones, right? It integrates really well into Qgis, and from several points of view. One is that actually when you have your history like that, you can move your data from the repo to Qgis quickly. You see there's a button on the left-hand side. So basically you can use that to actually export data, right? So you say, I want to see that data that is in the repo in the GeoGit format, in the GeoGit database, which has its own format. And I have imported that from whatever shapefile, PostGIS, whatever. It's now in the repo, and someone gives you the repo, or you clone the whole repo. It's like, okay, I have my data here, but how do I see it? How do I work with it? You can export it to a normal format, shapefile, or put it back into a PostGIS database or whatever. That then you can open with your software, in this case with Qgis. So it's pretty easy to have the full history. It's like, okay, I want to see this layer, this first one. So that means that the data at this point, 1 hour ago, etc. You click on that and you move your data to Qgis, where you can see it, you can style it, you can edit it, you can do whatever you want with it, right? Another good thing about the integration with GeoGet, with Qgis, is that we use some extra capabilities that Qgis has. Like in GeoGet, the only thing we do is versioning the data, but there are some other things that would be nice to do, like for instance supporting other types of formats. For instance, we don't support every single format, but if you use GeoGet through the plugin, Qgis supports many different formats. So when you want to put something into the repo, if the format is not supported by GeoGet, then there's no problem, because the plugin will use Qgis internally to convert that to a format that GeoGet can understand. So by putting that on top of a very functional GIS, what we get is extra functionality for GeoGet, right? And in the example that I will show, we'll see how you can actually export one layer and have like kind of live link. So whenever you modify your layer in Qgis, it gets updated instantly on the repo. So that will see like that. You have a diff viewer, which you can have the diff command that I showed you at the beginning in the command line. You can call diff to see the difference. It shows the difference. It can give you more detail than what I showed. It can give you actually coordinate by coordinate diff. But of course it's much better when there's a difference in the geometry. In that case, you see the corner has been changed, but it's much better to see it like that, right? There are other versions with a single map, and then the version that the kind of interface that you might have seen. They have slider, and you can just see both of them, things like that. So it's clearer like that. It's more user friendly. And then you see a difference in your attributes. In this case, the only attribute that I change is the geometry itself. You can see also in here. So basically we have the diff viewer that between two versions, you see between that version created at that date and the current last comment, those are the things that have changed. You can see the difference between any two versions in a very intuitive way, both for the geometries and the attributes. So this is one of the things. And of course, to render all the geometries, to style the geometries, etc., we use all the QGIS functionality, right? So it's just the reason why it's easy and good to put that on top of a powerful GIS like Qgis, because we can reuse all this thing, right? All these maps, they have like zoom and etc., all these typical things that we are reusing from Qgis. When you're going to do a merge between branches, as I said, you can have conflicts. So when you do a merge, there's a merge window that actually tells you, okay, what have changed in my branch, in the other branch, what things I have changed in both branches. In this case, there's just one feature that I changed in both branches. And actually it shows you, okay, this is when I'm going to merge, like the common ancestor, that means the value that we are all started. But you see in the two branches that we're going to merge, the local and the one to merge on top of that local, we have edited that differently. So I say, oh, maybe it's going to have a problem here. That maybe is going to cause a conflict, right? And you see it shows you the difference as well in the geometries, and you see that one of the polygons have an extra part in there. It has been edited differently. So it's once again a more visual way of visualizing all this, how things have been edited in both branches, etc., etc. Once you actually do the merge, if there's a conflict, in this case there's a conflict in the polygon, and there's a conflict in the area attribute, it's going to signal the conflicts, and then you have to solve them. You can just solve them as in the command line, just like, okay, get all the value from one branch or from the other, or you can do a more fine-grained definition just by editing directly the values and etc. Right? So this is the three-way merge tool. That is not similar to a three-way merge tool for source code, but this is the solution that we came up with, and well, basically this is what we have in the Qgis interface, which makes it more flexible and useful than actually doing this kind of things on the command line, right? There are some more dialogues and windows. I'm just showing a couple of them. This is one that is also pretty useful. You see the history of a single feature, so you just select one element. You can select that element from the list of elements in case there are not so much. If your data layer is really big, it makes no sense to have a list of them. And instead, you can just go on the map, put the layer in Qgis, and then you just can go with your just mouse and click on a feature, and you can see all the versions for that. So it just calls Geoget to report all the different versions. In this case, well, you see two versions. Just there, this is the full history, but not the full history of the repo, the full history of just that feature. And you click on any of the versions, and it shows you the different versions when that feature has changed. So that allows you to keep track of who and where and when has changed each one of the single features in your data, right? So basically that's the idea, having a Qgis plugin that allows you to do the same thing that you can do on the command line, more or less, but in a better way, more graphical. And since we are working with geodata and with geometries, well, it makes more sense, actually. And as I said, it brings also more power to GeoGet by using some functionality from Qgis, right? The other thing that's not related to Qgis, but it also uses GeoGet underneath, is the Geoserver Integration. So as I said, Geoserver uses this data stores, is the place where it takes the data from that then it's going to serve. So what we have created, it's a data store that is based on the GeoGet repo. So you put your GeoGet repo in the same way that you could use a PostGIS database or a shapefile with Geoserver that is supported that. Now you put your GeoGet repo, which is basically a folder in your file system, with all the version, all the data, etc. And it can provide the same services that it provides for the types of data, right? Like particular OGC services, that means that you can serve actually a map, a style map, or a WMS. You can actually serve the features themselves, the vector features, through a WFS service, but also you can serve through WFST. That means that on the client side, you can actually call your server to edit the data. So you can make new versions of your data, right, on that repo that is behind your GeoServer. By using the WFS transactional service, you can modify your data. So you can provide this capability to the user of that client to edit your data, actually, right? And that's a basic HTTP client API as well that allows you to do some GeoGet operations as well, right? This, forget to fix that, sorry, there's a screenshot that is missing. This is basically an application built on top of GeoNode, which actually uses GeoServer with a GeoGet repo behind that. So that data is coming from it's OpenStreetMap data, actually, on a version by GeoGet. I have a couple of screenshots for this. This is not here, sorry. So this is basically the current state of GeoGet. What I was trying to show you is that we have this software that you can use for version spatial data. It's similar to Git. It's currently fully functional. We can say feature complete. You can do all those workflows, putting data from your files or wherever you have your data into a working tree, and then move to the final version in the repo database. Do push and pull for interacting with other repos. So you have all the functionality. So where do we want to go now from there? And the main work that we are going to do now on GeoGet is basically to improve the performance and actually trying to make it more scalable. Like, we are really worried about making a GeoGet that actually works for no matter which is the size of your data, and it can actually be functional with not just large amounts of data, but large histories. Like, you can have a lot of thousands of different commits and edits like that. Our benchmarking here a bit is the OpenStreetMap planet. It's a massive amount of data, a lot of people editing it, lots of comments. So that's what we are kind of striving for, is to be able to have the whole OpenStreetMap planet and things like that. It's not a perfect example of data set because there are no branches, and we support branches. OpenStreetMap doesn't support branches, so it's just a linear history. But in terms of size and that, it's one thing that actually we like to be there. And one of the good things of having that, also what we strive to, or well, at least we would like to see, is actually managing the OpenStreetMap planet. Maybe not the central OpenStreetMap planet project, but there's some people that actually need to keep their own copy of the OpenStreetMap data, to handle that and manage that fully on a GeoGit repo. And that is good for many reasons. One of them is that, for instance, OpenStreetMap planet, you have the full data for the whole world, and you have the history if you want it. But that's a massive amount of data. But let's say that you want to have the data for Toulouse and just, maybe the full history, or maybe just the data for Toulouse during the last year. All the edits done during the last year for doing some kind of analysis or whatever. It's not trivial to get that. You have to actually download all the planet, use some tools to import that into your Postgres database, and do some non-trivial queries to get all that from there, etc. So it's something that it's seldom done because it's pretty tricky to do that actually. And if probably there are some people that do this extract of OpenStreetMap data, so you can get like all the OpenStreetMap data, the latest version for Germany, and you get it, and they give you shape files or whatever the format, or in some OpenStreetMap format, but it's someone that is actually taking care of preparing those extracts. So it takes work, and it's this non-trivial task that someone is taking care of that. When you clone your repo in GeoGet, you have your full history, your full everything. As I said, you just start working with that, you clone that. You can imagine that that's a big thing, cloning a repo that has the full OpenStreetMap planet, right? There are a lot of terabytes of data. Cloning that is not trivial. But we have some different modes of cloning. We have particularly two modes that we call shallow clone and a sparse clone. A shallow clone is a clone that you don't get the full history, actually. And a sparse clone is the one that you don't get the full data set, right? So I can say, okay, if I have, let's say, a repo with several layers, I can get a clone with just one layer and with just a short part of history. Or in case they have like the OpenStreetMap planet fully on a GeoGit repo, I can say, okay, let's clone this repo, but just here in Toulouse, and just give me this depth of the history, so you don't get the full history. So by doing that, you don't depend on someone just actually, doing things on the full OpenStreetMap data set with its history, but you just have it in GeoGit, but with a single common call, you can do that instead of going through all this non-trivial stuff, right? So it gives you more functionality, actually. It gives you more possibility because, the versioning system is actually, more advanced, let's say, or it has some different things, right? So that's the idea, that, it can be used for your data that you have already, like to start putting your data in a GeoGet repo. But also something like the OpenStreetMap, which is like something that almost everyone uses, this kind of data. You can put it in there, and then it gives you more functionality to do other things, right? But in case you want to get involved, this is I mentioned before, the place where we keep the data, our GitHub repo, we have mailing lists and issue trackers, etc. I will just give the presentation then to the organization, so probably they can download it. And it's an it's an open source software, so you can contribute and you can use this pull request mechanism in case you want to contribute. I think we still have time. Maybe I can make a small demo. It's going to be a short thing, right? So basically, I'm going to show you. I can show you the console interface, or I can show you the Qgis plugin. I'm going to show you a quick demo of the Qgis plugin. Just put in some data and edit in it. So it's going to be pretty easy actually. So what I'm going to do is to start Qgis. Right, and you see we have this plugin that is actually a GeoGit client. Right? So what I'm going to do is just show you a quick presentation of that. The first thing that I have to do is to start GeoGit gateway, which This is basically like, you can think of, oh, you don't see it because it's just on there. You see, well, I have, I started, like the last line you cannot see. But basically what I'm doing is starting a small server, right? This works like, imagine like a PostGIS database. You can access your PostGIS database from Qgis, but you have to have PostGIS running, right? And Qgis doesn't start that. Well, it's the same thing. You have to have your GeoGet server running so it's listening to calls from the plugin actually to do that. It's mainly for reasons of performance, so it's faster than actually calling it on the command line and having to start a new GeoGet instance each time. So we just have this small server and we just call it on there, right? So I open up my GeoGet client. I'm gonna delete that I had before. Yeah. Wow. And what I can do is add a repo. So what I can do is manage from here one repo that I already had, like I did it on the command line, or I clone it or whatever, or just create a new one. What I'm going to do is to create a new one, right? So you just select a folder where you want to put it. I have one folder created in here called repo. So I'm going to use this actually to create a repo, right? So this is going to initialize one repo at this location. That's it. Well, there's no last commit message because there are no commits, so I can open it right now. Right? Basically, you see the history in there. It's empty. Everything is empty. You know, it's like there's like a little part that is being chopped from that. So what I can do is actually put some data, and this is what I'm basically going to do. Let's see if I can make this smaller so I have more space in here to then show the data. So I can import my data from a QGIS layer, from a file that I have, OpenStreetMap data or PostGIS database, whatever. So I have several options. So I can go to here, for instance, some examples that I have. This is from the GeoGet tutorial. If you go to the geoget.org website, you can find this. There's for a quick start, and you have this data, this parks data, right? So basically what I'm doing is importing the data. In this case, I know the structure, so the field that I'm going to use for the feature ID is not ID, but FID. But basically I'm telling like, take this layer, put that layer into my repo, so we start working with it, right? So once it's in the repo, then GeoGet can recognize things, compare things, etc. If it's on the shapefile outside of the repo, there's no way GeoGet can do anything, right? Oh, maybe that's not an FID one, and I was wrong. Yeah. Okay. Yeah, that's like. Well, this is another thing that the plugin does. That it's a little bit easy to make some errors, not actually errors, but when you need a like kind of primary key for identifying your features, and the shapefiles don't have that primary key. So then it's pretty easy to have some problems with that, and the plugin kind of takes care of that. Like if you don't have a primary key, we'll create it for you or similar ones. So you see that now I can close that, and I see that in there are no versions yet. I haven't created any new version from the data, but it's well, you have in the working tree, you have at least 3 new features in one layer. So that means that it knows that from the latest version, which doesn't exist, it's an empty repo, there's some change, right? So I can actually view those changes. And let's see, well, these are the changes. I have added 3 new things. This is a very small layer called parks, and I can see what I've done. You know, there was nothing before, now I have this. Okay, there was nothing before, now I have this, right? So basically those are the differences. That's pretty obvious. So I can create a new commit and actually create a new version. So like this is going to be the first import. And you have my first import in there, and I start to build my history. Right. So now I can, if in case I get this same parks layer in here, I can get rid of that. So now imagine that you clone your repo, you get that repo and say, okay, I want to start working with that. It contains this data of this parks, so I can actually take the data and edit. How do you do it? Well, I'm going to export. You don't see, yeah, you see in there parks 3 features, the last line, and I can actually export that. So it's like take that layer from this version, which is the latest one. I could have hundreds of them, but from that one, take that layer, and you can actually export it, put it into my repo. There you have it. I have three different polygons, so I can have it, and now I can edit. And now, since this layer comes from the GeoGit repo, Qgis knows that it comes from the GeoGit repo. So that means that if I now do something like this, talk about editing, like I get my node tool. I say, okay, going to change something in here, right? I edit this layer, this goes fine. And I say, okay, this has changed, and let's make a new version in the repo, right? So what is the change that you made for this layer? It's like, modified polygon. That's what I've done. Modified polygon, whatever is the number. So and you see the changes that I have actually not added anything, not removed anything, just modified one, right? And there it is. I have a new version in my history, so I can just go now to this one, and I can see the difference that I added in here. And you see this, the difference that I added in this between this last and the previous last one. You see the first import and the current last one. It's just in the layer called parks, feature number 3. This is what I've changed, and this is I've moved from this to that. And you see the geometry has changed. You actually are seeing that the area and perimeter has changed. I have actually changed them, but that's a small bug that still has to be fixed. It's a matter of precision, that when you put those things into QGIS, it removes some of the precision values, and actually that's the problem that we're having. So that actually hasn't changed, but it identifies it as changed. But so you see, this is what I do. I can put things in a single map as well. So you see that both of them, and I can see it differently. I can see the changes from that I've done like that. And that's basically the idea of the plugin. I just wanted to make this pretty quick demo. So the idea is that once you have your layer, now you can edit this layer, and it kind of keeps track of the of what you do on the layer, because it knows that it comes from a GeoGit repo. So whatever you do, it's actually going to modify that. And so that's something that you don't have if you just use the console version. If you use the console version, you just have to take your shapefile, for instance, you import it, and then you just do whatever in your same shapefile with whatever the software you want to use, and once you have it, you have to re-import it manually again. Once it's re-imported, you go to the working tree, you then create a comment. So it's more powerful, the workflow, but it's a little bit not so user-friendly. It might be a little bit awkward. But the idea is with this plugin is to make this easier for users that are more GIS users than Git users or developers or people more experienced with version control. It's actually you just work on your data, do whatever, and then you have that. Right. So you can create your branches and do things in here. It's also powerful. You can merge. You can then synchronize with another repo. So I can I don't have any remote repo, but I can define a remote, like someone else is doing things on the remote. Well, what I can do is I can show you that. Actually, I can add a new repo, which is going to be this same one that I have added, right? The repo one. It doesn't have to be a local one. Of course, it can be a remote on a different machine. It's like, imagine that's the URL to a different machine. So it's like I'm cloning this one, right? I'm cloning this repo actually to my repo clone. So I'm just taking that repo and creating a new copy, right, of it. So I get this repo clone in here, right? You see it's the same one. It says it's been modified because it keeps all the history of the same one. I can open it, and it's actually the same one because I have cloned it. But if I go to the sync repo, there has an origin repo, which is the first one that I created. I can actually manage the remote. And you see the origin one, it's a remote repo. It's in there. So if I do any new change, I actually can show you how to do that. So I can just go here and do some of the change in here. Whatever I can move this. Move future. Whoop, I move that one. Do the same thing. I've moved the polygon. I should keep my history in there. Oh yeah, sorry. I made this. This layer here is not linked to the clone, it's linked to the original one. So if you go to the original one now, it has modified the original one, right? You see move polling, right? So now this one, I have this one, right? And the other one that is the clone of that one, the repo clone. So I can change back to my repo clone. Okay, here. And I can say, okay, let's see if there are changes, right? In the other one that I cloned, maybe someone altered that. So do you have any changes? I can pull the changes. And you see actually now in my clone, I have fetched that change that someone introduced on the other one. So you see the different clones are related, right? So I guess that basically that's it. That's the idea. So you see that in case you want to participate, in case you have questions, you can go to our website, of course, and of course if you want some information, you feel free to write me and I will answer you. I'm part of the GeoGet development team, and I'm actually the author of the Qgis plugin. So if you have questions related to any of them, just feel free to contact me and I will just answer them, right? And I guess that's it.
How about we take questions at the end, Victor? So that
yeah, I think the better. Yeah, we can. So it's better in the end to have all the questions all together and some more discussion. So I leave the place to Manuel. Do you want to sit here?
What? No, I'm here.
No? Okay. Okay. Maybe, I don't know if the camera is pointing at me or there, but if he's going to talk, maybe you have to move the camera to point at him.
You don't want to focus on you the whole time?
I don't mind, but maybe it's not going to be that interesting for other people. I don't know if it's pointing to the screen, or maybe you can sit in here. Yeah, I've seen both. Okay, great. But you don't see that?
It's changing.
Okay.
The screen.
Okay. My name is Manuel de la Calle. I come from Spain, from Globe3 Mobile. First of all, thank you for coming to the workshop. Sorry for my English. I will try to do my best, but probably probably you do not understand all the things that I want to say, but simply question me and I'm going to respond. We are Globe3 Mobile. The company is called Globe3 Mobile. We talk about mobile map technology. That is our framework SDK that we have developed in the last 2 years. Before now, as Globe3 Mobile was the name of the library until 3 months ago. But now we are on the LocationTech. We have changed the name of the library for trademark issues. Now our name is Mobile Map Technology. Okay, it's cool the name, and we are here with the Eclipse Foundation and the LocationTech. Okay, what is mobile map technology? It's an open source SDK API Well, the repository is maybe the font is a little small, but you can look for the repository in GitHub and look for Glob3 Mobile. In the next months, the repository is going to change to an Eclipse repo, but currently we have this GitHub. As I saying, it's an open source. You have all the code we are developing directly in the GitHub. We don't have private repositories for customers, of course, but the main branch is GitHub, and we directly are developing there. We have a very liberal license. We have now a BSD license that I suppose you are familiar with license, open source license, but in other cases very liberal, and you can do with the code what you want. We're going to change to Eclipse license, but it's going to be the same license, IPL, okay, but it's the same. But we use for the SDK is to build native maps application. Later I'm going to talk about why native maps, but the idea is to develop native application for maps. Also, the applications are in 3D or 2D. You can select that you want. That runs on any device. The idea is a multi-platform library to face different problems you have when you are starting a mobile development. And the idea is that you can run our framework wherever in using native APIs. Okay, this is the thing that I'm talking before. When you start a mobile development, I suppose some of you are working with mobile. We have several problems, and everybody needs to face the same problems with the maps and other issues problem of the GIS. You have problem with fragmentation in the part of the hardware and the part of the software. With the software, you have the problem. You have different platforms with different languages. If you want to do something in iOS, you need to do the things in Objective-C. If you go to Android, you have Java. And if you go to the web or desktop, you have all languages. Actually, you have a lot of problems with fragmentation. With the hardware, everybody knows. You have thousands of screens, especially in Android, thousands of processors, memory, graphics capabilities. This is a very big problem for maps. It is impossible to see the map in the same way in two different forms. If you are an iOS developer, you don't have that problem because you have only 3-4 screens per solution. But Android's world is really complex in that. Other problem is the performance. The performance, in our opinion, the maps are a highly performance application. You need to do a lot of things to show in a good way map. At the end of the day, show a map is only to show a photo JPG or a PNG in the screen. But to show maps in a good way, you need to go the image fast, and you know to handle the multi-touch behavior of the application. You need to manage the cache to save your maps and to work offline, the GPS. But there are a lot of things. As the performance is a big problem, is one of the biggest challenges for developers when trying to show their maps. We have decided to go to native application because it's the only way to have the best performance for your application. Most of people are trying to do maps in HTML5 that have some advantages, but with libraries like our, you have the same complexity to have your maps on the device, much better performance. When you are working on HTML5, it's not easy to have very good maps. And the other problem that we face from the beginning, because we are writing the library from the scratch, is the usability. Some libraries on mobile are ports of libraries that are working on desktop environments. Yes, it's a good approach, but the work on mobile is pretty different, because you have to, mainly because the resolution of your pointer is a finger, not a pointer of mouse. And you can have 2 pointers with the hands. There are different things to handle the maps on mobile. This problem we have faced from the beginning. Our library is prepared to work on the mobile world with the usability, the correct usability for the mobile. How we do that? How we have a multi-platform SDK to work with maps. As we want to have native APIs, we need to have code in all platforms, but we don't want to develop we won't develop 3 different SDKs, because it's a lot of work. Our idea at the moment was develop a core in C++ that is common. You can, when I say common, I'm saying that you can compile C++ everywhere. All the core, the main classes, the classes that provide us most of the functionality, the low-level functionality, was written in C++. This code is translated. Simply we translate the C++ to Java. When we have the Java version, with a translation tool, it's a very simple translation tool. With this Java code, we have reached to Android, and also an HTML5 version using GWT, Google Web Toolkit, that works really fine, and will give us a JavaScript version. At the end of the day, we have iOS version, that is the C++ code merged with C or Objective-C in the iOS environment. We have the Android version with the native libraries, and you work your application in Java on Android. We have the version in JavaScript via Google Web Toolkit. The application on Android and Google Web Toolkit shares 75% the code, because GWT is written in Java. You write in Java and you click the button and you have the JavaScript code. This architecture allows us to add new platform very easy, very easy. We have to compile, we have to fight with the native problems of every platform. For example, now we are developing the Windows 8 version. The way to have this library was, first of all, we compile in the Windows compiler. Okay, we compile, we fix the problems with the different C++. And now we have to develop the concrete parts of every platform. And in the Windows 8, our problem is we have to write the DirectX that is similar to the OpenGL, because we have a lot of graphics, stuff in the library. But it's a work of 3-4 weeks. Probably we'll have a Windows 8 platform. For the user, the user doesn't mind to worry about that. You get your Android platform if you're an Android developer, and you work with a normal Android SDK or iOS, or you work and But if you want to work multi-platform, you have to translate both in the same way or work with different applications. We do the both things depending what our application is worth. Which are the capabilities of our platform? Well, as we've seen before, is multi-platform. And at the moment, iOS, Android, and HTML5 JavaScript. This is an example on Android, and the other example is iOS. There are not a lot of open source software on iOS platform. And in the map, I don't know if you are familiar with GIS applications, but in GIS, there is an open source software. But our library is open, and you can develop iOS application with it. But this is the same thing. The screenshots in your right are in the Google Glass. That is an Android device, but to port to Google Glass was immediately. We only have to put the library there. And the other is in the browser. The browser, when every browser that can run WebGL, gets WebGL. And at the moment, all browsers, inclusive Explorer 11. But the WebGL version in Explorer works more or less. You have different views. You can work with globe view with 3D, a 3D globe view, and you can handle the globe with fingers, and it's very fast. I can show after a demo. A scenario, we call the scenario a part of the map. You give to the API a bounding box, a part of the terrain, and we cut the terrain in different places. We have a digital terrain model in this example, or you can add 2D maps, normal 2D maps, but it's not 2D. Actually, it's a 3D maps, but the world is flat. When we say here any kind of data, it's any kind of data. We can put practically every data you have on vector or raster. Always with data transformation, because we are from the beginning. We know that all the GIS environment, and we know that there are thousands of libraries that can convert data in a very good way. We don't reinvent the wheel. We only have some parsers, mainly GeoJSON or binary JSON, and we simply transform the data. But transfer the data and all the data transformed is easy to include in our platform in this one. And now we have a demo in a video, and I can explain you better which is every kind of data. This is another different capabilities that you need when you are working with maps. One of the most important capabilities is you can work online or offline, and your data sets could be shared in different platforms. We are using SQLite. If you have a map stored in the database, you can share the map into different platforms. Everything you download from your server, from the internet, is saved on the device if you want. This is a developer. This is an SDK. It's a developer tool. If you want to cache, you can cache, and you can manage the cache. You can manage the cache expiration, etc. Because when you are developing a map application, some of data is always the same. For example, the base layers, the photo normally change, I don't know, one time every 6 months or every year. And for example, the real-time data is changing all the time. You can put real-time data that is changing. You can put data that is all the time on the device. It's in the cache and counts very fast. We have a 3D environment. Some some concepts are different from the maps, from the 2D maps. Where when you are working with 2D maps, we are working with the scale. In the scale, make no sense in 3D environments. We have a camera, and the camera have a pitch, a rotation, and height. It's not the scale is a concept for an ortho vision of the map. We have all the auxiliary stuff to manage the camera. You can put the camera where you want. You can move the camera. You can do what you need. We have model animation. Basically, animation. We had animation with the other utility that is here. There's the tasks. The tasks are as a la loop. The task is you can have a differentiation task that only is done at the beginning, and you have periodical tasks that is that the SDK manage to do every a period of time. You have model and you are changing the position every time the model is moving. We need all this stuff because we are in different environments. We have with asynchronous environment like the XML part, and we have completely synchronous environment that is Android or C or the C part. We have to manage that. We ask to the user. The user doesn't mind if the environment is synchronous or asynchronous. You only use the task and you only work in that way. We have a lot of data transformation tools, but only in the specific part to go to our library. The mobile application, the mobile map application are not only a device problem. It's a client-server application normally. And you have some information that is good to have on the server, and that information that is good to have on the client. And it's not always there isn't a result to do that. Depending the data, depending your capabilities, depending your requirements, you have to do one thing or another. We have all the things you need to do that. Our data transformation tools allows you to have your data in a very optimized format to go to the mobile. I want to put a video. After that, I will go to open the Eclipse, and with a few lines of code, I will to develop a very small application. I put the video. This application that you see there is in Google Play or in iOS on the Apple Store. You can download the application. All the things that you see on the application, you can see the code. The code is in the GitHub. If you want to learn how it's done, you only have to go to the GitHub and see how. It is our documentation, because we are not maybe we are developing, and maybe it's not very well formal documented the software. But the demo application normally are enough to show how to start with the application. This is the raster. You can see here this is casted with my telephone. It's smooth, it's easy. You can change with the fingers. There are different raster layers. Practically every raster layer you want could be shown on application. It's very easy to add especially the tile raster layer like OpenStreetMap. And we have some classes to put whatever. Okay, continue. This example are two blocks together. This work on Android, you can put 4, 5, 11 you want, or your screen, or or you can have in your screen. This is a scenario model. We have a digital terrain model and another layer raster layer. This example can be done with 10 lines of code, more or less.
The video is real time, it's not speed up. The video you're taking, it's real time.
No, yes, it's real time. Yes, it's real time.
Speed up, so it's quite,
Yes,
quite
and
fast.
this is the speed on Android. In iOS it's better. We have to fight a lot with Android because you have the Java virtual machine and the garbage collector. And Android is a lot of time triggering the garbage collector, and we have a little stops sometimes. But for example, with this data that could be cached, is going very smooth. You can try on here. This is the handle of the fingers is pretty different in another application because we detect in some moment that the two fingers to change the pinch is very confused. It's very hard to know when you are changing the camera, and we use 3 fingers to do that. This is a design, and this is other thing is we use 1 finger and you fix the finger and the tune is going where you have. It's also pretty different with other SDKs, but when you are familiar with that, you don't want to return to the others because it's very fast. It's very fast and it's very easy to handle them out. We think that multi-touch maps are the future. Now we have bigger and bigger screens to, for example, in Windows 8, there are a lot of computers with multi-touch screens. This is idea to do the Windows 8 version, but Apple is thinking in launch iPad bigger. Maybe the next laptop is going to be multi-touch capabilities, and of course all the Android companies is going to do the same than the others. The multi-touch management is very well done. We spend a lot of time working on that, and we are always working on the performance. Why? Because it's our big difference with the HTML applications. If you have a map that is with stops, or you have the tune is slow, you go to a leaflet application and works fine. This is the same maps with terrain. Normally, the problem with the data is not is with the parsing of data. It's not with the drawing. This is vectorial data. This I'm doing click on the forget. What to say? This is we have a very powerful symbology library. This is vectorial data also, but it's shown in another way. As we have 3D, we can do different things. And these shapes take the value from the alphanumerical data. Also, if you have a periodical task, you can do this data change. I can show you, for example, I want to show. We have a sample on all platforms. In this example, we have exactly that. This is real estate price in Spain after the bubble, and the prices are getting down. And this is symbolic. And we merge that with with graphs. You can use D3 because this is JavaScript. It's normal JavaScript, and this is done in Java. To have this application on Android. Actually, when you are developing a WebGL version, and you develop the Android version at the same time, most of the time, because you only have to develop the interfaces, the user interfaces. That sometimes are short tags, or times it's a big task. This is the same. We have the way to put labels, to put shapes, to put spheres, different things. A different way to show the information. This example, is more time. Why? Because we are parsing a million points. It's a linear cloud. We have the way to show LiDAR in streaming via server. We have the format. We know how to order. It's not still developed, but this is a proof of concept that we can show every point cloud independently decided. Because if we can show a million points, the only way is to send the points in an ordered way. We know how. As you see, with these points, you can move fast. You can see here the trees, the roads. It's a normal point cloud. Remember this now. This is a 3D model moving. We have this application a little more complex. So this was a demo for an airline company. It's a flight from Boston to Frankfurt. You have in theory, they want that to have on the plane, getting the data from the aircraft instruments. All the data is on the plane. We have cached the photo, the things. We have this functionality, but we can do what we want. For example, this is point of interest. This is a point of interest for German. It's a mountain. You can see the terrain. This is easier to move with the mouse. You can return to the plane. We have a lot of data from the plane, and it's very easy to put the plane in during all the moments. We have the pitch, we have the rotation. It's very smooth, as you see. We have different views. For example, the view. I love the view. The other view is an automatic view. Then it's changing the views because it's thinking. This is thought for have on the big screens of the plane or on the device of the user. You connect to the server of the plane, and you have on your application. You can see how is the plane going. But this is an example. But basically in the SDK language, this is a 3D model with a periodical task that to the periodical task is change the position of the model all the time. I never remember the parameters. For example, here is a version. This is a version with 3D buildings. These 3D buildings are for OpenStreetMap. And you can move on the map. This is Boston. And the plane is moving and the 3D map is moving. Okay, continue with the video. This is the flat map. It's flat, but you can change the angle of the camera. But it's a flat map. Yes. That is all maps. This is nothing special, but it's raster map. So, also raster map, different raster map. Because little hard to put because they have the tiles with a different way to open a stream map, but with this we change classes with reverse engineering the JavaScript. The root tree of JavaScript you can see always what you need in the JavaScript. This is the sample of the plane that I showed previously. As we have 5 minutes. Yes, we have 5 minutes more or less. I want to show you, I don't know if you are developers or you know, I suppose you know the Eclipse. I want to show you how to develop an application in exactly 5 minutes. But the easiest way to start with developing mobile is going to our repository, as I said before. On the repository you have, for example, I want to use the Android version. You go to Android and you have the demo. The demo is just the same that is on the Google Play. And when we change a little the demo here, we try to have the same on the Google Play, but you can compare. And the SDK. This project and the testing application is a project where we use when we are developing to write fast and effective. I'm not recommending to use that project. You can see new features, but sometimes it's trash. The Hello World project, that is basically the project that I want to develop now. It's a very easy project. The same with the other tools, with the WebGL. It's learning for the user for the 3D models and the AI version. That is here. We have a small wiki and we hope to grow getting started. As you see, we have a little lack of documentation. I start a project. Project. The minimum SDK is not needed. But normally works better. Work sex, reference, okay. Works better, creativity, okay. Mediating, where's the sample, okay. Like the thing. Activity. Okay. Well, now the last version of this comes with the fragments. I want to quit all the fragments because we don't need it now. I don't know how familiar are you with Android development. This is our version. Activity. Okay. I want to delete the fragment. So the name. So need for me. Also for me. The home plate that we need. We need some permissions. Which is the best way to do that? Copy. I go to the demo project. The demo project is in the GitHub. If I want to do something like that, I go to Android, Word, Manifest, write standard stories, video version, blah blah blah. Go to my manifest. And have the correct listing. What do you need to do at the application with Block3 Mobile? You need to have our library. You only have to go to the path, press up to Android, and we have a library. You need to have import this library on your workspace. I have started with a workspace a little configured, but if you have a workspace from the scratch, you only have to do this project. You only have to have this project, the G3M Android SDK, that is a library. And you have to do in the path, you have to have in the path the project, the SDK share. The share code is the translated code, and the SDK is the code that is from the platform. When we manage the things that are only for this platform, we have all we need. We have the manifest. Now I need to prepare my layout from an Okay, that's our layout. I go to copy another time. I know that this is a very similar application, and I only put in a relative layout with a linear layout inside. You can put in the relative layout or where you want. It's a normal Android widget. Okay. We have all things we need that is not Java code. We go to the main activity. We have the content view of the activity main. For example, I have the scenario terrain activity that is very similar. That is a very simple example. First of all, I create the builder. We use the builder pattern because we have a lot of, when you are creating a globe, you need to set a lot of things, thousands of parameters. Also with layers. You can specialize, or you can use or you could use the builder. Using the builder, you have a globe directly working in a minute. Also, the builder has all the methods you need to write application. I don't know one, but they have a lot of methods. Okay, we have the builder, and the other thing we need is the widget. The widget is exactly as the name are indicating, is the widget that you go to inject to the Android. You go to the builder and say to create the widget, create the field, okay. Finally, you only have to add the view to the layout. I remember I put a linear layout, okay, and the number was Block3, and the sample changed some things, okay. Okay. Bye. So this is with this. Only with this, we have. I hope we have a globe. Run as Android application. My phone is connected. Oh well, it's here. Okay. The same with the same capabilities. You only have to change the data that you want to put and put different things. For example, I have defined why. Meanwhile, Victor is talking. I'm looking for the coordinates of Toulouse. And for example, this is the way to define a bounding box. Some things are a little different from another GIS application because we have to manage, for example, in angles, because we're working on a 3D environment. But we have all the auxiliary methods, auxiliary libraries to work on the same way. We're working on geographic coordinates. You can define angle from the grids. The sector is the same that a bounding box, but it's a little different concept because it's not exactly a box. But with the curvatures of the world, it's different. We have a sector. I have defined my sector. I want to put another layer. I want to put a map box layer. That is a very cool layer. Okay, I have defined this layer. We have, for example, we have some auxiliary classes. For example, for map.layer, layer, we have the map.layer layer class. You only have to put your ID. We have defined the layer set. Okay, this is a layer set. Wait. We have the layer set. We have the sector, and now we have to add the layer to the builder. Builder, what is the builder? Yes, builder. Okay, we set the layer set. And now we have to add sector, where is the sector? Yes, we go to say to the application that we only have the scenario. We only have this part of the world. We have the method set sound sector. The name is terrible, but works. And we put the dense sector. We put the dense sector a little shrink. We have to with this map. I never test that. I hope it works now. You have to have the terrain layer with the Toulouse Toulouse bounding box. I launch. I hope it's working. Now this is a demo. I see it. And we have Toulouse. If you have a digital terrain model, you only have to, for example, in the scenario terrain model, this is the code of the repository. This is public code. This is the code of the application. You only have to put your elevation data provider. In this case, the URL is in our assets file of Android. Yeah, in every platform you have to do different things, but this is thought for developers of different platforms. It's okay. It's done. If you have questions or something, it's the moment. Thank you.